Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a solved numerical on the topic Newton's law of motion, D'Alembert's principle or connected body, whatever. Let's go to the numerical. Two blocks as shown in figure have masses A 20 kg and B 10 kg, and the coefficient of friction between the block A and the horizontal plane is 0.25. If the system is released from rest and the block falls through a vertical distance of 1 meter, what is the velocity acquired by it? Neglect the friction in the pulley and the extension of the string. Okay. Here, the diagram is given. There are two blocks, A and B. A is having a mass 20 kg. B is having a mass 10 kg. The object A that lies on a rough horizontal surface. The coefficient of friction between the horizontal surface and the sliding object A that is given as 0.25. Okay. And then another object B with the mass 10 kg that is connected by using a string, and the string is passed over the pulley and connected to the object A like this as shown in the figure. Okay. In case the object B falls through a vertical distance 1 meter, that means from here, if you consider this is the initial position, from this position in vertical direction 1 meter, if the object B falls, then we know that when this object B moves downwards, due to the object B and A connected by using a string or thread, the object A that will move towards right side. Okay. So the direction of motion of the object B that will be downwards. The direction of motion of the object A that will be towards right side. Okay. So from this initial position, if the object moves or falls through a vertical distance 1 meter, what is the velocity acquired by it at the end of 1 meter? That here we are going to calculate. Okay. If the string is not there, for an example, if I cut here, okay, if I cut here, cut the string here, then it will act as a free fall motion. Okay. But whenever it is connected by using a string, that means the connected bodies, here it will not act as a free fall, but it will act as normal linear motion or motion in straight line. That means if I cut here, then this object will fall under the influence of gravity. That means the downward acceleration due to gravity. G 9.81 meter per second square. So if I cut here, this object will fall under the influence of gravity. But here when it is connected by using a string, it will not fall with the influence of gravity, but it will falls or it will moves with some constant acceleration. Okay. So that acceleration first we have to calculate. Okay. So here as usual we will consider the free body diagram of A and free body diagram of B. Then the forces acting on A and B separately. Then we will form two equations. By solving the two equations, we will get the tension and acceleration. By using the acceleration, we will calculate for vertical distance 1 meter, or from this position at a vertical distance 1 meter, what will be the velocity it will get. That we are going to calculate. Okay. First, I just tried the given data. Okay. So here, the given data. Then here there are two masses. Mass of object A that I'm going to consider as M1, that is 20 kg. Mass of the object B, that is M2, that is 10 kg. The coefficient of friction between the horizontal plane and the object, that is 0.25. The vertical distance in which the object B is going to travel or falls from its initial position, that equal to 1 meters. Okay. Then here we are going to find the velocity. Okay, we are going to find the velocity at s equal 1 meter. This we are going to find. Okay. So here, first I'm going to consider the free body diagram of A. Free body diagram of the object A here. Okay. So just consider the object A lies on the horizontal surface as we discussed here. Okay. The object lies on the horizontal surface, and then what are all the forces will act on this body? That here we are going to discuss. Okay. So here you can see this is the object A with the mass which is equal 20 kg. When this object lies on a horizontal surface, its weight m1g that will act exactly downward, and equal and opposite force exerted by the surface to the object, that is reaction force R1 or normal reaction. Here the tension, that is an equal and opposite forces acting on the string, that will act for the object A towards this direction, and for object B that will act towards upward direction. For object A towards right side, for B it will act upward. The two equal and opposite forces, numerically equal, direction wise opposite, the two tensions that will act on the string, since A and B, the two bodies are connected by using the string, then the tension will act on the string. So for the free body diagram of A, this tension in the body A that will act towards right side. Okay. And then here, the ultimate direction of the object B, that is downward direction, object A, that is towards right side. Okay, that means for the object A, the direction of motion, that is towards right side. That is the direction of A. The same way, the object to B, the direction will be towards downward. So this is the direction of the object B. Okay. So we know that when this object A over the rough horizontal surface is moving towards right side, the frictional force, I am going to consider capital F to denote friction small f for the object 1. So object A 1. Okay, F1, force of friction 1 or frictional force in the object 1. Because here the direction of motion is towards the right side. So frictional force that opposes the motion. So that will act towards left side. Then the inertia force numerically equal to M1A. That will also act on the opposite direction of motion, opposite to the direction of motion. That means M1A. That force also will act towards left side. Okay. So here, when you considered this inertia force that equal to the summation of external force, then as per the D'Alembert's principle, this will be in dynamic equilibrium. So we can use any one of the equations of the equilibrium. That means summation of horizontal 0, summation of vertical forces equal 0, summation of moment about any point equal to 0. That things we can use. So first, summation of vertical forces equal to 0. Here, there are two vertical forces are there. R1, the normal reaction force, which is acting towards upward. M1G, which is acting exactly downward. So these two forces will act opposite to each other. So R1 that equal to M1G. We have the value of M1, that is 20 kg multiplied with G value 9.81 or otherwise 9.8. So we will get R1 that equal to 196 Newton. Okay, R1 equal 196 Newton. Then summation of horizontal forces equal to 0. Here, what are all the horizontal forces are acting on the object A? The tension that is acting towards right side, when the direction of motion of A that is towards right side, frictional force opposite to the direction of motion towards left side, M1A, inertia force, that also will oppose the motion. So that is also towards left side. So these three horizontal forces, one is towards right side, tension that equal to the left side forces, summation of the left side forces, M1A plus capital F, F1. And this FF1, frictional force in the object 1, that equal to the product of coefficient of friction multiplied with the normal reaction in the object 1, mu into R1. Mu, we have the value 0.25 multiplied with R1. We calculated as 196 Newton. So the force of friction or frictional force in the first object, we will get 49 Newton. Okay. 49 Newton. So if you substitute the 49 Newton here, and then we have the value of M1 that equal 20 kg. So this we can write as tension that equal to M1, that is 20 kg multiplied with the acceleration, that is also the unknown, plus 49. Okay, so by rearranging this, we can write T minus 20A that equal to 49. Okay, so this is the first equation. Now we are going to draw the free body diagram of the second object. Okay. So for the second object, it is a second object B. It's a freely hanging, okay, by using a string. Okay. So this is object B. Okay. This is object B. And then this going to be attached on a string. Okay. This is going to be attached on a string and like this. So this is the tension in the string like mentioned in the diagram. Actually, this will be the free body diagram of object B. Okay. Here we know that the direction of motion that will be downward. This is the direction of motion for this object. Okay. Here it is freely hanging. It means that it is not having any surface or point contact with any surfaces. So here there is no normal reaction. Okay. But the weight of the object, which is equal to m2g, that will act exactly downward. Okay. And the inertia force, as per the D'Alembert's principle, this will act opposite to the direction of motion. Here, the direction of motion of the object B, that is towards downwards. So, the M2A inertia force, the product of mass and then acceleration, that will act upwards. So, these three forces will act on the object B, which is having 10 kg. Okay. So now here only vertical forces are acting. There is no horizontal forces. So we can take summation of vertical forces that equal to 0. So the upward forces, there are two upward forces are there. Tension plus M2A that equal to the downward force, that is M2G. So we can write T plus M2A that equal to M2G. Here substitute the value of M2 and G. M2 is 10 kg. So 10 multiplied with the acceleration, that equal to 10 multiplied with 9.8 or 9.81. So we will get this equation as T plus 10A that equal to 98 Newton. So this will be the second equation. So now we have two equations. Okay. T minus 20A that equal to 49. This is the first equation. T plus 10A that equal to 98. That is the second equation. So by solving these two equations with the two unknowns, we can calculate the unknowns, tension and then the acceleration by solving equations 1 and 2. Okay. The first equation, T minus 20A that equal to 49. Second equation, T plus 10A that equal to 98. Second equation. So here I'm going to solve these two equations. It's better first cancel this T. So we have to subtract the equation 2 from 1. That is 1 minus 2. So here we will change the signs of the equations 2. That means here it will become minus T. This will become minus 10A. This will become minus 98. So this plus T and minus T, that will cancel each other. Then this minus 20a minus 10a, that is minus 30a, that equal to minus 49. Okay. So acceleration equal to 49 divided by 30. So we will get 1.63. So acceleration equal to 1.63 meter second power minus 2. Now substitute the acceleration value in any one of the equation. Okay. Better substitute in the second equation. So substitute in equation 2, that is t plus 10 multiplied with 1.63, that equal to 98. Okay, that equal to 98. So if you multiply 10 and 1.63, you will get 16.3. So t plus 16.3, that equal to 98. So t equal to 98 minus 16.3, we will get 81.667 Newton. So this is the tension in the string. So these two unknowns we calculated. Actually here the tension is not needed, only the acceleration is needed. So but whatever, that is also the unknown that we can calculate in this numerical. Okay. Then here we have the acceleration. As I mentioned earlier, if I cut here, okay, that means if I cut the string, then the object B that will fall under the influence of gravity. That is, it will move downwards with a value of acceleration due to gravity, that is 9.81 meters per second square. But here, this is connected by using a string with the object A, which is sliding over a rough horizontal plane. So this object will move downward, but this will not move with that much acceleration. That means due to the gravity 9.81, but here it only moves in the downward direction. That means comparatively less than the acceleration due to gravity. That is 1.63 meter second power minus 2. Only with this much of acceleration, the object B, the body B with a 10 kg will move downward. Okay. But if I cut here, it will move with the value of acceleration due to gravity. Here, just to take, this is the initial position. Okay. From this initial position, the object is going to fall down. That means in vertical direction. This will be the final position of the object. This vertical distance, that is given as 1 meter. This is initial position. This is the final position. When it falls, the vertical distance 1 meter. With this acceleration 1.63 meter second power minus 2. What will be that? That means I'm going to take this position is O. Okay. This position is O, and then this position is A, B, C. Okay. This position is C. So what is the velocity at this point? Velocity at C. That is the required velocity. From this position, O, or initial position, when the object falls with 1 meter to C, that is the final position, what will be the velocity at C? When it moves downward with the value of acceleration 1.63 meter second power minus 2. So here This we can take as motion in straight line with an acceleration 1.63 meter second power minus 2. Okay, so we need the value of velocity, and then when it start to fall from this, we can take the initial velocity at this point, that will be 0. Okay, because from that it is going to move downward. So we can use the equation v square equal u square plus 2as, and then when it start moving from rest, its initial velocity is 0. The first term will be eliminated. So we can write v square equal to 2 multiplied with the value of acceleration. We calculated as 1.63, and then the vertical distance 1 meter. So if you simplify this, we will get v square. Okay, then v equal under root square root of 2 multiplied with 1.63. So we will get the finally the velocity that equal to 1.81 meters second power minus 1. So this is the final required value. Okay, so here two blocks are given, A and B, 20 kg, 10 kg. 20 kg block is moving over a rough horizontal plane. The coefficient of friction is given. The block B, it's a freely hanging and that will move downward. Okay, this A and B, the two bodies are connected by using a string. So the tension will act like it's shown in the diagram. We considered the free body diagram of object A. We got one equation. Then free body diagram of B. We got another one equation. By solving these two equations, we got the value of acceleration. By substitute the value of acceleration in any one of the equation, we got the value of tension. Okay. Then velocity acquired by it when the block falls through a vertical distance from rest. Okay, so here if I considered this is the initial position where it start from rest or released from rest, its initial velocity is 0 at a traveling distance 1 meter at point C. What is the velocity we have to find? So v at C we have to calculate when its initial velocity is 0, acceleration is known, s equal 1 meter. So v square equal to u square plus 2as, cancel the first term. So v square that equal to substitute a and s, then take the square root, we will get the velocity equal 1.81 meter second power minus 1. Okay. Okay guys, I hope you all understand this video. Don't forget to subscribe my YouTube channel Vishwaguru, a problem solver, for more videos on this topic, Newton's law of motion or D'Alembert's principle, and in further topics. Okay, so don't forget to subscribe my YouTube channel Vishwaguru, a problem solver. Okay guys, thank you. Thanks for watching.